Okay, so for this deep dive, you guys have really sent us some wild stuff this time around. We're talking about like what would happen if the sun exploded.
Right, right.
And and then of course, full disclosure, our sun, it's not going to suddenly just like go supernova on us.
No, no, not at all.
It's just not in the cards for our particular star. But stick with us here because even though this whole scenario is totally impossible, it actually forces us to think about something really profound, something we often just kind of take for granted.
I totally agree.
I'm talking about the sun's role, its absolutely vital role in, well, literally everything around here.
Yeah, yeah.
When you really dive into this thought experiment, it becomes crystal clear that the sun, it's not just like some cosmic light bulb up there. It's more like the very foundation, the scaffolding that holds our whole solar system together. And if it were to vanish, well, everything would unravel in some really fundamental and really disturbing ways.
Absolutely. It's almost like we're using this impossible scenario, this what if, as a kind of a lever to pry open some really deep insights about how our solar system actually works, how it all fits together, and how unbelievably reliant we are on that giant ball of fire in the center of it all.
Exactly. And the crazy thing is, it's not like people are walking around totally oblivious to the sun.
Yeah.
We all kind of know it's important, right? It's
Yeah.
just like there.
Right.
But the stuff you sent us, it really hammers home just how unbelievably crucial it is to the point where it's almost hard to wrap your head around. Like, we're talking about the literal engine of life on Earth.
Yeah.
It's the source of all the heat, all the light, the raw energy that drives absolutely everything. We're talking everything from the tiniest little microbes to the biggest trees, from the weather patterns, the jet stream and the ocean currents and all of that, to, I mean, let's be honest, even our own moods, right? Whether we feel like getting out of bed in the morning. And the thing is, without the sun, Earth, it wouldn't just get a bit chilly, a bit darker. It would turn into this completely, permanently frozen wasteland, a black, icy world that's just utterly hostile to any kind of life that we know of.
What's really interesting here is that it forces you to think about the sun from a different angle. Like, it's not just this passive energy source, right?
Wow.
It's more like a fundamental structural component of our entire solar system.
Okay.
Like that massive gravitational pull it has. That's what keeps all the planets, including us, locked in their orbits. It's like an invisible chain holding everything together. And if that chain were to snap, well, we wouldn't just gently drift off into space. We'd be flung out into the void with incredible speed, lost forever in the cold, dark emptiness between the stars. And then there's the sun's magnetic field, which is kind of like this amazing shield, constantly deflecting all these harmful cosmic rays that would otherwise just bombard our planet and make things really, really unpleasant for us. So yeah, the analogy that gets thrown around a lot, the cosmic guardian, is actually pretty accurate.
Like a powerful image, right?
Yeah.
This thing that's so familiar, so constant in our lives, it's also our protector. And it makes you wonder, what if that guardian just disappeared?
Yeah.
Like, imagine you're going about your day totally normal, the sun's shining, everything's good, and then poof, it's gone, just like that. What would happen? I mean, that's the really scary but also really fascinating question this whole impossible explosion scenario
Yeah.
makes us confront.
Exactly. So let's really dive into that impossible scenario.
Yeah.
The sun exploding like a supernova. Now, we already said that our sun can actually do that. It doesn't have enough mass, enough fuel to trigger that kind of colossal explosion. A supernova is the death throes of a much bigger, much heavier star. But for this thought experiment, let's ignore that little inconvenient truth and just imagine the consequences.
So the stuff you sent us, it lays out this pretty grim timeline of what would happen. And the first thing you really have to wrap your head around is the speed of light. Like, the sun is pretty far away, about 150 million kilometers, which is 93 million miles, I think.
Right.
And it takes about 8 minutes to travel that distance. So even if the sun were to suddenly explode, we wouldn't know about it for a full 8 minutes.
Yeah.
Like, everything would look perfectly normal. People would be going about their day totally clueless. And then, bam, the end.
It's a really stark reminder of how limited our perception of the universe actually is, isn't it?
Totally. It's like we're living in this bubble of the present, and we have no idea what's already happened out there waiting to catch up to us.
Yeah, it's a bit unsettling when you think about it.
But even if we did have those 8 minutes, what could we actually do? I mean, what possible action could you take facing something like that?
Right.
It's almost too big to even comprehend.
And then after those 8 minutes, the side of Earth facing the sun, that would be the first to get hit, and the impact, it would be absolutely unimaginable.
Yeah.
You're talking about this incredibly intense wave of radiation on a scale that's just beyond anything we can really grasp. Like, the atmosphere would instantly get superheated to insane temperatures. The oceans would literally start boiling away. Forests all over the planet would just erupt in flames. And anything, I mean, anything that's exposed to that initial blast would be vaporized in an instant, just gone.
So it's like this instant global firestorm.
Pretty much.
And you might think, well, okay, maybe the night side of the Earth, that would be safe.
Right.
Like at least there, you'd be shielded from that initial wave.
You might think that, but the thing is, this explosion wouldn't just be some localized event.
Okay.
It would release this mind-boggling amount of energy, and some of that energy would come in the form of neutrinos.
Neutrinos.
Yeah, they're these tiny, almost ghost-like particles that can pass through almost anything. They could travel straight through the Earth.
So even if you're on the other side of the planet.
You'd still be affected. And while the main radiation wouldn't hit the night side right away, the sheer amount of energy released would heat up the whole planet incredibly fast, making the entire surface everywhere completely uninhabitable in a very short amount of time.
Wow. And then after the light comes the shock wave. Right.
Exactly.
But that travels slower than light, so it would arrive a bit later.
Yeah.
But from what I understand, the impact could be just as devastating.
Oh, absolutely. Like, we're talking about the potential to rip away Earth's atmosphere completely or just bombard the planet with a massive amount of stellar debris.
Which makes me think, even if we were underground, wouldn't the shock wave from a supernova just, like, shatter everything?
Yeah, that's a really good point. Like, the seismic forces unleashed by something like that, they'd be immense.
Right.
Definitely something to consider. And then there's another huge consequence. The loss of the sun's gravity. Like, right now, its gravity is what keeps us in orbit, but without it, Earth would just become this rogue planet drifting aimlessly through space.
Oh, wow.
No more nice, stable orbit around the sun, just this cold, lonely journey through the void.
And the temperature, it wouldn't just slowly get colder, right? It
Yeah.
would be this sudden, drastic drop.
Yeah, like within a week, the average temperature on Earth would plummet to something like negative 18 degrees Celsius, which is 0 degrees Fahrenheit.
0 degrees. That's insane. I can barely handle that for a few minutes, let alone, trying to survive indefinitely.
And then just a year later, it would drop even further to like negative 73 degrees Celsius, which is negative 100 Fahrenheit.
That's just, like, unimaginable.
And think about what that would do to the oceans. They'd start freezing from the surface down, forming this incredibly thick layer of ice. And over time, even the atmosphere itself could potentially freeze and collapse, becoming this layer of solid gas covering the planet.
So it's not just about the cold. It's about the fundamental state of matter changing on a global scale.
Exactly.
And on top of all that, without the sun's light and magnetic field, we'd be constantly bombarded by cosmic radiation and meteoroids, just stuff floating around in space that the sun normally protects us from.
It really does paint a pretty bleak picture. The end of life as we know it.
So, with all that in mind, it's hard not to ask, could we survive? Like, even hypothetically, if we had, let's say, years of warning before this impossible explosion happened, could we do anything?
That's where things get really interesting. Like, it pushes us to imagine some pretty wild survival scenarios. And
Yeah.
one of the ideas that comes up a lot is this concept of going underground.
Underground.
Yeah, like literally living beneath the surface.
Mm.
Because a few meters down, the temperature is much more stable. It stays around 17 degrees Celsius, which is about 62 Fahrenheit.
So you're talking about building these massive underground bunkers, right?
Yeah, almost like self-contained little worlds. They'd have to be super sophisticated, though. You'd need sustainable food and water, air recycling systems, and some way to mimic sunlight for growing crops.
It sounds almost like a futuristic mole people scenario.
Kind of, yeah. And from what I've read, some people think these bunkers could theoretically support humans for, like, up to 1,000 years.
1,000 years?
Yeah. But, and this is a big but, it's only a short-term solution, because up on the surface, everything would still be frozen solid. It wouldn't be a place you could just walk out into.
So eventually we'd have to find somewhere else to go, right? Like another planet, or maybe build some giant space stations orbiting a different star.
Exactly. And that's where the scale of the problem becomes really apparent.
Like, how do you even begin to move billions of people across interstellar distances?
Right. And then there's the issue of finding a suitable planet, one that has the right conditions for life, the right atmosphere, the right resources. And even if we could find one, terraforming it, making it truly habitable, that would be an undertaking of epic proportions.
So even if we could survive the initial explosion by going underground, escaping Earth entirely, that's a whole other level of
It
challenge.
really puts things into perspective, doesn't it? Like
Yeah.
it makes you realize just how incredibly lucky we are to have this perfect little planet with this perfect little star that keeps us alive.
Totally. But thankfully, our sun isn't actually going to explode. Like, that's not its fate.
No, no. It's going to go through some pretty big changes eventually, but it's going to be a much slower, much more gradual process. We're talking billions of years.
Okay, so let's talk about that. What's the scientifically accurate future of our sun?
So we're looking at about 5 billion years from now, and at that point, the sun will have burned through most of its hydrogen fuel. And that's what powers it right now, that nuclear fusion in its core. So when that fuel starts running out, the sun's going to start expanding. It's going to enter what's called its red giant phase.
So it's going to get bigger.
Much bigger. Like it could potentially get so big that it engulfs the Earth's
Whoa,
orbit.
whoa, whoa, wait. Engulf the Earth's orbit like we'd be inside the sun.
It's a possibility. But even if that doesn't happen, the heat from the red giant sun would be so intense that Earth would become completely uninhabitable long before it could get swallowed up.
Okay, so red giant, that's not good. What happens after that?
So after the red giant phase, the sun's going to shed its outer layers. It's going to create this beautiful, expanding cloud of gas and dust called a planetary nebula.
Nebula.
Yeah. And what's left behind at the center of that nebula is a white dwarf. It's basically the sun's core, super dense, but much smaller than the sun is now.
So it's like a tiny shrunken sun.
You could think of it that way. And over billions of years, that white dwarf will slowly cool down and fade away.
So it's a much more like peaceful ending than a supernova.
Definitely. It's a gradual, predictable process. And it really puts things in perspective, doesn't it? Like, compared to the instantaneous destruction of a supernova, this is a much slower, more drawn-out event.
Absolutely. And it makes you think, with billions of years to prepare, maybe humanity could actually adapt to these changes, maybe even find a way to survive them.
That's a really interesting thought. Like, who knows what kind of technology we'll have in 5 billion years? Maybe we'll be able to travel between stars, maybe even shield entire planets from the heat of a dying sun.
It's mind-blowing to even try and imagine. But even though our sun is going to go through these changes, it's also going to leave something behind, right?
Yeah, definitely. Like the stuff that gets ejected during the red giant phase, that gas and dust, it doesn't just disappear.
Oh,
It becomes part of this vast cloud of material between the stars, the interstellar medium, and eventually some of that material will clump together and form new stars, new planetary systems.
so in a way, the sun's death could lead to the birth of new worlds.
Exactly. And on those new worlds, maybe new life will emerge, maybe even intelligent life that will look up at their star and wonder where it came from, completely unaware that the materials that make up their world, their very bodies, were once part of our sun.
Wow. That's incredible. It's like this cosmic circle of life, death, and rebirth.
It really is. And it makes you think about our place in all of this. Like right now, we're here on Earth, orbiting this star, living our lives. But in the grand scheme of things, this is just one tiny chapter in a much bigger, much longer story.
Yeah.
And that story is going to continue long after we're gone, long after our sun has died.
So just to be crystal clear, the exploding sun, that was just a thought experiment, right?
Right.
A way to explore some really interesting ideas, but not something that's actually going to happen to our star.
Exactly.
But even though it was hypothetical, it really made us think about some important stuff, like how much we rely on the sun, how fragile our existence really is.
Absolutely. And maybe, just maybe, thinking about these kinds of cosmic scenarios, even the impossible ones, will push us to learn more, to innovate, to maybe even find ways to overcome challenges that we can't even imagine right now.
It's definitely food for thought. And to our listeners out there, I want to leave you with this. Take a moment to really consider our place in this vast, incredible universe. Think about all the possibilities, all the stories that are unfolding out there right now in this moment on planets orbiting distant stars. And remember, even though our sun will eventually die, the story of the cosmos, the story of life itself, it's going to continue, maybe in ways we can't even begin to comprehend.
It really makes you wonder, doesn't it? What's out there, waiting to be discovered? What kind of future awaits us, or maybe even the descendants of humanity billions of years from now? It's a pretty awe-inspiring thought.
Absolutely. And that's what makes exploring these ideas, even the seemingly impossible ones, so fascinating.